Welcome everyone to this comprehensive tutorial on Asyncio in Python. As modern applications increasingly rely on performing multiple tasks simultaneously, understanding how to manage asynchronous operations effectively is crucial. Asyncio is Python's built-in library designed to handle these asynchronous tasks using an elegant and straightforward syntax. Throughout this tutorial, I will explore Asyncio's core concepts, learn how to create and manage coroutines and tasks, and see practical examples of how Asyncio can streamline your projects. Let's start with the basic. Asyncio is a Python's built-in library that allows us to perform multiple tasks concurrently, making our applications faster and efficient. Here is an example. In this example, we first import Asyncio Python's built-in library because it has a great features that can perform executing of multiple tasks concurrently. Then we define the main coroutine. The function is called a coroutine because we define that function using the keyword async. This coroutine helps us to perform tasks asynchronously. Then there is asynchronous operations. For example, await asyncio.sleep that pauses the coroutine for 5 seconds after executing hello. Then it continues executing the second statement, that is worded. To execute the coroutine, we call the function asyncio.run, and we call that coroutine inside that function. When you run this program, you see that hello is printed out, then it pauses the executing of the coroutine for 5 seconds, and then it continues printing out the wordlet. To understand Asyncio, we need to know about the coroutines. The coroutines are special functions that defined using the keyword Asyncio that can pause and resume execution of the program. The event loop manages these coroutines efficiently. In this example, the coroutine is the main function and is defined for the asynchronous execution. Then the asynchronous pause, that is await asyncio.sleep, that pauses the execution of the coroutine for 5 seconds. And the event loop management just manages the overseas of the execution of the coroutine. The coroutine is the building blocks of Asyncio. Coroutines are the foundations of Asyncio. They allow us to write asynchronous code that's easy to understand and maintain. In this example, I have defined fetch data coroutine. This fetch data coroutine fetches the data asynchronously. Then it pauses for 5 seconds, and it continues executing the fetched data after 5 seconds. So the code executes sequentially, fetching and printing that data. Then we call this coroutine inside another coroutine, that is the main coroutine. And finally, when you call asyncio.run and call that coroutine, the main coroutine inside this function, it executes the code and it's going to sequentially execute the coroutine. So you see that fetching data, then it prints data is fetched sequentially. All right, what is the event loop? The event loop is the conductor. The event loop is like the conductor of an orchestra managing the flow of executing in our Asyncio application. In this program, the event loop controls the execution flow of the coroutine. Then the next example I'm going to show you is how to execute multiple coroutines simultaneously. In this example, we have 3 different coroutines. The first coroutine is say hello, that prints hello after 5 seconds. The second coroutine is say wordlet. It just prints out wordlet after 1 second. In this example, we can run multiple coroutines concurrently with Asyncio that improving performance. The asyncio.gather function helps us to perform the multiple execution of the coroutines. The third coroutine is main coroutine that uses Asyncio together to run both coroutines concurrently, that enhancing the performance. For example, when you run this program, which coroutine is printing the statements first? Either the first one or the second one. Let's try. Yeah, as you can see on the output, the word is printed out first because the coroutine is just paused for 1 second. Then the second coroutine is paused for 5 seconds. So in Asyncio, the multiple programs are running concurrently. So the first one it is not executing sequentially. It just executes concurrently. And the second coroutine is just paused the execution of the coroutine for 1 second. The first one is 5 seconds. So just first prints out the statements in the second coroutine. Then after prints out coroutine state. The statement is in the first coroutine. So that's why we call it is a synchronous program. Multiple program can run simultaneously. And this gather function in Asyncio can help us to perform the execution of multiple coroutines concurrently. All right. For example, if you change this to 6, hello is first, world is second, because the first coroutine just waits for 5 seconds and the second coroutine just 6 seconds. That's it. So it just pauses the execution of the coroutine for some times. If it reaches to that time, it continues printing out the statements. Another is tasks and await, simplifying async operations. As we navigate the intricate landscape of Asyncio, we encounter two invaluable allies, tasks and await. Together, they streamline our asynchronous operations, paving the way for elegant, efficient code. In this example, we define a fetch data coroutine, and the data fetched is printed out after 5 seconds, and there is a task that is scheduled in the main coroutine, asyncio.create task. So the fetch data coroutine embarks on its quest to fetch data asynchronously, then creating a task. Asyncio.create task is delegated the coroutine's task to our trusty servant, the task, and awaiting task completion. With bated breath, we await the task's completion, eagerly anticipating the results and reaping the rewards. As the task fulfills its duty, we revel in the fruits of our labor, greeted by the eagerly awaited results. When you run this, you can see that the task is scheduled for 5 seconds, and then it awaits the tasks and prints out the data is fetched. All right. The last but not the least is real-world examples how to implement Asyncio. In this real-world example, I'm going to show you in this real-world example, how to use Asyncio to fetch data from the internet. As we conclude our journey through the Asyncio, we encounter a real-world scenario, fetching data with HTTP requests with AIO HTTP library. We translate the boundaries of synchronous programming, embracing the limitless possibilities of asynchronous execution. I first define Asyncio and AIO HTTP library by importing those libraries for asynchronous HTTP requests. Then they define the coroutine fetch data, takes the parameter URL, and async with AIO HTTP.client session as a session, and then we get the response of the URL, and it returns that response. In the main coroutine, we just call the function using await and pass the URL into that function, and it prints out the data. And finally, we call asyncio.run and call that main coroutine inside that asyncio.run. And when you run this code, you can see that the data is fetched from the internet by using these HTTP requests. If you request multiple HTTP requests, it just executes concurrently and fetches the data from the internet from multiple websites. So this Asyncio is very, very crucial for improving the performance of our applications. As we wrap up, let's reflect on our journey through Asyncio. I have covered the basics, explored by concepts, and witnessed the real-world applications of asynchronous programming by leveraging coroutines, the event loop, and powerful libraries like AIO HTTP. We can build applications that are not just fast and efficient, but also scalable and robust. Thank you for joining me on this journey through Asyncio tutorial. I hope you are now equipped with the knowledge and tools to harness the powerful potential of asynchronous programming in your Python projects. Happy learning.